Hi, welcome to lesson 7 of vectors. Today we're going to look at unit vectors. Okay, so what is a unit vector? Well, a unit vector is just a vector that is 1 unit long. And the symbols we use for unit vectors are the letters I, J and K. So if we start at the origin and we go along 1 unit in the x direction, that is the unit vector I. So I is the unit vector in the x direction, and because it's only one along the x-axis, it has a column vector of 1, 0, 0. Likewise, if we start at the origin again and we go 1 unit along in the y direction, this is the unit vector j. So j is the unit vector in the y direction, and if we think about it in terms of its coordinate, there's no horizontal movement. We're going 1 in the y direction and then there's no vertical movement, so it has a column vector of 0, 1, 0. And then lastly, starting at the origin again, if we go 1 unit in the z direction, this gives us the column vector k. Or sorry, should I say the unit vector k. And in terms of its column vector, there is no horizontal movement, there is no movement in the y direction, and there's only a movement in the z direction vertically, so therefore we have the column vector 0, 0, 1 for the vector k. Okay, so any column vector can be expressed in terms of the unit vectors I, j and k. So let's look at an example. Here we've been given 3 coordinates A, B and C, and we're asked to write the position vectors of the coordinates and then write them in terms of the unit vectors I, j and k. So A is the coordinate 2, 3, minus 1. Remember, the position vector is just that coordinate as a vector relative to the origin, so we just write it vertically and we use the lowercase symbol a, and that is a is equal to 2, 3, negative 1 written vertically. Now what does this mean in terms of the unit vectors? Well, we have an x component of 2, so remember that means we've got 2 lots of 1, 0, 0. Then we've got a y component of 3, so we've got plus 3 lots of 0, 1, 0. And then we've got a z component of negative 1, so that tells us we've got subtract 1 lot of z, which is 0, 0, 1. So in terms of just the letters, that's 2i plus 3j minus 1k. Let's look at b. So b is the coordinate point minus 4, minus 5, 2. So therefore our column vector would be lowercase b is minus 4, minus 5, 2 written vertically. To get it in terms of I, j and k, we have got negative 4 in the x component, so that's going to be negative 4i. And then we've got negative 5 is the y component, so that's negative 5j. And then we've got positive 2 is the z component, so that's plus 2k. So we end up with negative 4i, subtract 5j plus 2k. Lastly, we have c, which is the coordinate 1, 0, negative 5. So again, the position vector is just lowercase c, and we write 1, 0, negative 5 vertically. Now here we have an x component of 1, so therefore we've got 1 lot of 1, 0, 0. We have no y component this time. So the y component, well, the y component is 0, so we have no unit vector for the y direction. So there's y, j should I say, will not be in this representation. And then lastly, we have negative 5 in the z direction. So we end up with just I subtract 5k. As I said, there's no j in this expression because the y component was 0. Okay, in the last slide we expressed column vectors in terms of unit vectors I, j and k, but we can do the opposite thing as well. So this time we're going to look at the unit vectors expressed in terms of I, j and k and changing them back to column vectors. So example A, we have 2i plus 4j minus 3k, so we just need to remember that I corresponds to the x component, so the x direction. J corresponds to the y component, the y direction, and k corresponds to the z direction. So we end up for A, we've got 2i plus 4j minus 3k. That just gives us a column vector of positive 2, positive 4, minus 3. If we look at B, we have got 1i subtract 3j plus 1k. So that's going to give us a column vector of 1 minus 3, 1. For C, we have 4i plus 2j. So notice here we don't have a k term. So in this case, we're just going to have positive 4, positive 2, 0. So 0 represents the fact that we don't have the k term here. We look at D, we have 2j minus 3k. In this case, there is no I term, so the x component will be 0, the y component is positive 2 because we have 2j, and the z component is minus 3 because we have minus 3k. So as a column vector, we have 0, 2, minus 3 to represent 2j minus 3k. For E, we just have negative 5k, so there is no I term, so that means the x component is 0. There's no j term, so the y component is also 0. We only have a k term, and that will be minus 5. So the column vector for negative 5k is 0, 0, minus 5. We have a last example here, F, which is I plus 6k. So notice here there is no j term, so that means there will be 0 in the y component. Okay, so we have negative I, so that represents negative 1 as in the x term. We've got no y component, okay, and then plus 6k, so therefore our z component is 6. So we have minus 1, 0, 6 to represent negative I plus 6k. Okay, let's look at a last example before you try some questions yourself. So here we've been given a diagram of a coordinate point A, and we've been asked to write down what the coordinates of A are, then express the vector V in unit vector form. So that's in terms of I, j and k. So here we can see to get to the point A, we need to go from the origin, we need to go left 3, so remember to the left is negative, so that gives us an x coordinate of negative 4. We need to come back 2, so remember coming back the way in the y direction is negative also, so that gives us a y coordinate of negative 2, and then we need to go up 6. Now up is positive in the y direction. So our full coordinate for point A is negative 4, negative 2, 6. If we want to express this in a unit vector form, we need to express it as a position vector first of all. So vector V can be expressed as negative 4, negative 2, 6 written vertically. And then remember your x component corresponds to I, your y component corresponds to j, and your z component corresponds to k. So we could rewrite this as negative 4i subtract 2j plus 6k. Right, let's have a go at some questions now. Okay, if you can go to Vectors Worksheet Exercise 7, please, and have a go at just question 1 and 2 just now for the time being. Check your answers and then come back to the video for the rest of today's lesson. Okay, we're going to look at the final part of today's lesson, which is just resultant vectors and magnitude with unit vectors. So just from previous lessons, remember your resultant vector is just the vector produced when you add or subtract a set of vectors. And the magnitude is just the length of a vector, and we get that from our Pythagoras. So the magnitude of vector AB is the square root of the x component squared plus the y component squared plus the z component squared. But we can incorporate that into examples that involve unit vectors, because we now know that we can change from the unit vector form back into the component form quite easily. So let's look at example 4 here. We've been given two vectors in unit vector form P and Q. P is the vector 2i plus 3j subtract k, and Q is the vector 6i subtract j plus 4k, and we've been asked to find the magnitude of each of these vectors. So, firstly, we just need to think about it in terms of the components. If we have 2i, that means we would have a value of 2 in the x direction, so that would be 2 squared. We've got 3j, so we have a value of positive 3 in the y direction, so that would be 3 squared. And then we have negative k, so that means we would have negative 1 in the z direction, so we would have plus negative 1 squared. So here we can just write this as square root of 2 squared plus 3 squared plus negative 1 squared. And working through that, we get the square root of 14, which is 3.74 units. Similarly, if I wanted to get the magnitude, the length of vector Q, it would be the square root of 6 squared because I have positive 6i, plus minus 1 squared because I have negative j, plus 4 squared because I have 4k. So that's going to work out as the square root of 36 plus 1 plus 16. And if we work through that, we get the square root of 53, which corresponds to 7.28 units, rounded to 2 decimal places. Okay, one last example before you go on and finish the rest of today's exercise. So here in example 4c, we've been given two vectors u and v. U has the unit vectors 3i plus j is subtract 2k, and v is 5i plus 3j minus 4k. Now here we've been asked to find the magnitude of the resultant vector 4u subtract 2v. So before we can find the magnitude, we actually need to find the resultant vector. So what is 4u subtract 2v? So that's going to be 4 times the column vector 3, 1, minus 2, because for I we have, for u we have 3 lots of I plus 1 lot of j and then minus 2 lots of k. And we're going to subtract 2 lots of v, which is 5, 3, minus 4, because we have 5i plus 3j and minus 4k. So we just need to multiply those out. So we end up with 4 3s are 12, 4 1s are 4, and 4 times minus 2 is minus 8 for the first vector. And then multiplying the second column vector by 2, so we're subtracting 10, 6, minus 8. And we end up with 2 minus 2, 0 as our resultant vector. So now we have the resultant vector, we have an x component, a y component and a z component that we can put into our Pythagoras formula. So the magnitude of 4u minus 2v, remember you need the vertical line either side for the correct symbol, and that's the square root of 2 squared plus negative 2 squared plus 0 squared. So working through that, we get the square root of 8, which is 2.83 units to 2 decimal places. Okay, so today's lesson's been quite straightforward. Time for you to go and have a go at the rest of the questions. Okay, last part of today's lesson then, if you can go back to your exercise 7 and complete questions 3 to 9. Once you've done that, please make sure you mark your work and do any corrections, and then upload your work onto Class Notebook, and that's you done for today. Okay.